Just as important as the numbers on the periodic table are some of the names that we're going to be using when we're referring to the periodic table. It all has to do with a little bit of the organization of the elements within. We know that they're organized according to their properties, and because things are organized according to their properties, they tend to be called the same type of thing. Let's give you for instance here. One way that we could organize the elements on the periodic table is according to the metallic character. Now that's a property that tells us how metally or how non-metally an element is. All the elements here in green are known as the metals. The orange elements are known as the nonmetals, and the purple elements are known as metalloids. What I really want to draw your attention to is a couple different elements here. Element number 1, all the way at the top left-hand corner, that's hydrogen. Notice that that's colored in as being orange. He is typically referred to as a nonmetal. Also, take a look at the top of this important feature called the staircase. The staircase is what divides the metals from the nonmetals. And at the very top of the staircase, the element that stands on top of it is boron. Boron is considered to be a nonmetal, and right underneath that in row 13 is aluminum. Aluminum is the first element underneath the staircase and is always considered to be a metal. And then from there, anything that touches the staircase is considered to be a metalloid. Now, it's important also to understand the differences between these three groupings. Metals are elements that tend to be very malleable. That means that they're easily bent. Ductile means that they can be pulled without breaking into a thin wire. They tend to be silvery in color, except when you're talking about things like gold or copper. And they're excellent conductors, not only of heat, but also electricity. Nonmetals are the exact opposite of that. If you can push and pull and hammer and do all of those wonderful things to metals, you can't do that to a nonmetal. They tend to be very, very brittle. Instead of silvery, you tend to have very colorful elements in the nonmetal characters. And also, instead of being really great conductors, they tend to be terrible conductors of both heat and electricity. Now, metalloids, because they're sandwiched in between the metals and the nonmetals, tend to have properties of both. And it depends on exactly what kind of property that you're looking for. They kind of varies as you're going through the metalloids. Now, more than just metals, nonmetals, and metalloids, we have different larger groups on the periodic table. Everything in red here is something that we refer to as the representative elements. These are most of the elements that were first discovered on the periodic table, so they tend to represent a lot of the chemistry which we tend to do. You can see the elements that are being left out here. The representative elements are often referred to as the main group elements. Now, sandwiched in between these two segments of the main group elements are the transition metals. We typically don't do a lot of chemistry with the transition metals because they tend to be a little bit more on the naughty side. And you'll understand why as we go into our next unit. At the bottom of the periodic table, this kind of disembodied section here is called the rare earth metals or rare earth elements. A lot of very interesting chemistry happens down here as you start to have a lot of radioactive elements. Now, more than that, the structure of the periodic table, we need to discuss that as well. Now, we can discuss the rows on the periodic table, but instead of saying rows, we tend to say periods. Now, this is in deference to the periodic table. Now, periodic means repeating in a pattern, and the properties within a row tend to change in a pattern. If you stack one row on top of another, the properties change almost exactly the same way as you move across that row. A lot of that has to do with the electrons. All of these things have the same number of electron shells as you move across from the beginning of the row to the end of the row. That's an important thing to understand. Up and down, the columns on the periodic table are referred to as families. Some textbooks even refer to these as groups. Now, what's important to understand about a family or a group on the periodic table is that all of the elements within a family tend to have very similar properties. As you move from top to bottom down a family, every space you move down one, you're going to be gaining an electron shell. All of the elements inside of a family or a group tend to have the same number of valence electrons. And you're probably looking at the screen right now saying, oh my goodness, what does valence mean? Well, valence is just a fancy way of saying the outermost shell. So all of the elements within a family will have the same number of electrons in their outermost shell. Now, each row, because they tend to have very similar properties, we like to refer to them as a family name. The elements in the very first row are called the alkali metals. They are very soft, very silvery metals. They tend to be also one of the most extremely reactive groups on the periodic table. We'll play with a couple of these in lab and learn a little bit more about their properties. The second family on the periodic table, the second family, are known as the alkaline earth metals, followed up by the transition metals. Next comes the boron group, and what's interesting about the boron group is it contains a mixture of metals, nonmetals, and metalloids. Same thing with the carbon group, the nitrogen group, and the next one is going to be a surprise. Instead of saying oxygen group, the official name is the chalcogens. The halogens, this again is a very reactive family on the periodic table. One of the most reactive elements that we have on the periodic table is fluorine, all the way at the top of this column. And lastly, the non-reactive noble gases. Now, down at the bottom, we also have the rare earth elements, and there's 2 rows on the inside of there. We name them separately. The top row are known as the lanthanides, and the bottom row are known as the actinides. And we'll go again in a little bit more in depth into the properties of each family on the periodic table a little bit later, and also in lab. I have found it very, very helpful to label a periodic table with the names of these families until you really know them.